Hi everyone, in case you don't know me, I'm Akif and I'm making a quick video on 6LoWPAN. This is my blogging site and this video won't be a detailed description of the 6LoWPAN, however, it will be an overview. If you want to delve deeper into this 6LoWPAN thing, then I will be giving some links below in the description, and you can also refer to this book, which is a 6LoWPAN book, The Wireless Embedded Internet. It was written by Zach Shelby and Carsten Bowman. It was the first book on 6LoWPAN, and they both are very much involved into these protocols and all that stuff. So what is 6LoWPAN? Some circles also refer to it as nano IP, but 6LoWPAN is IPv6 or low power wireless personal area networks. So low power wireless personal area networks, which in IEEE world is referred to as 802.15.4, are very small devices or small microcontrollers, which are 8-bit or 16-bit microcontrollers, and these are also referred to as constrained and low power devices. So getting them on internet or getting them involved with IPv6 was one of the major breakthroughs in the IoT world, and you can think of them as the small processors. So whenever we look at the processors, we usually think of the processors as the processors we have in our laptops or desktops, but if you look at the facts, 98% of the processors that are being designed throughout the world, they are not used in our desktops or our laptops. They are involved in all these applications, wireless sensor network applications, all these constrained devices. So when we have these small devices, we think of these devices as having the sensing ability. They sense the temperature or accelerometer, or they even sense the light, and they have the sensing ability, they have the processing ability, and they have the communicating ability. When we talk about the communicating ability, we can think of it as a separate island of these small constrained devices or these IoT devices. If you look at this figure here, there is this island or domain which is formed by these IoT devices, and what connects them together is a 6LoWPAN, and one of the key one device that plays a key role is this edge router. It does three main things. It exchanges the information between this 6LoWPAN island with the rest of the internet. So it helps these to get on the internet, and it also helps in allowing the communication to happen between these devices or in this domain. And it's also responsible for the generation and the maintenance of the radio subnet. Now, when you look at this 6LoWPAN island, all these devices have one thing in common. It's this prefix. It's this IPv6 addressing format. All these devices will have this IPv6 address, and they all will share the same common prefix. You can look at it here. This device has this address 1, 2, but they share this prefix. This prefix is common to all. So there are two types of devices, routers and hosts, and they all play a crucial role, and we will be explaining it shortly. Now, before allowing this IPv6 to be a part of these the communication that is happening between these low power and constrained devices, it was a very challenging task. So what happened was that IETF developed a group that was responsible for making this happen. So when they designed it for the first time, there were two crucial challenges. One challenge was that of the data link layer. We know each data link layer allows and has a limitation of the data that can be sent at a time. So the frame size for this link layer for 802.15.4 is 127 bytes, and out of these 127 bytes, a part will be used for a header and a part will be used for the payload. So we will be having only some bits, maybe 80 bits, that can be kept for the payload. On the other hand, the minimum value of the maximum transmission unit for IPv6, which is a layer above, which is the IP layer, which comes in the network layer. It's a layer above the data link layer. So the minimum value of the maximum transmission unit for IPv6 is 1280 bytes. Therefore, it was a challenge. It's just, if we talk about it figuratively, it's just like putting an elephant over a small ant. So this IETF group, or 6LoWPAN group, they developed an adaptation layer that will break these higher layer stuff into small chunks, and then it will be sent to the data link layer. So some circles show the 6LoWPAN or adaptation layer as a separate layer, as you can see here. It's a layer that is between our network layer and the data link or MAC layer. But if you look at the implementation, it's one and the same layer. IPv6 and 6LoWPAN layer, they come in the network layer. And if you look at and compare it with the protocol stack that we commonly use, is TCP/IP protocol stack, and if you compare it with the 6LoWPAN protocol stack, you will see a difference. A difference is that in TCP/IP we have TCP, but in 6LoWPAN protocol stack we don't have a TCP. The reason is that TCP is very complex kind of protocol. It involves a lot of complex computations. It involves the three-way handshaking. It's reliable, so it needs much more memory, or it needs more resources in comparison to UDP. UDP is not that much heavy. It's a best delivery protocol, which is a good word for it. What does that mean? It means like you are sending a letter to your friend and you hope your best that it might reach to your friend. Then what happens to the letter in between, you don't know. It can reach, it can be destroyed, it can be lost, anything can happen. TCP, on the other hand, we have this reliability part. You know there is an acknowledgement. So how do we come up with the reliability in this 6LoWPAN stack, or devices that are getting into this IoT world? That is provided by this application protocol, and one of the famous application protocol is CoAP. And we will be making a separate video on this, and if I don't make a video, there is I have written a whole article about CoAP in my blog. You can refer to that. Another thing about 6LoWPAN is its neighbor discovery. If you think of it, if you try to equate it with the neighbor discovery in IPv6, it's not one and the same thing, because when the neighbor discovery in IPv6 happens, it's like everyone is shouting at everyone. Everyone expects that everyone is on and is working at the same time. But same you cannot expect in 6LoWPAN. As I said, some devices, they sleep, they wake up after weeks. So in the IPv6 neighbor discovery. Let me show you, give you an idea about what IPv6 neighbor discovery is. So there is this host and there is this router. There are four main what you call as ICMP messages are involved in this. One is router solicitation, another is router advertisement, another is neighbor solicitation and neighbor advertisement. When you talk about router solicitation, it always originates from the host. So this message is sent to find the router on the link. The router, on receiving this router solicitation, it responds by router advertisement message. Router advertisement message is another ICMP message which originates from the router, and they are used to indicate the presence of the router on a link. Router advertisement messages are sent periodically by the router in response to the router solicitation. Then comes the neighbor solicitation. Neighbor solicitation is a message that originates from the nodes to request the link layer address of another node that it wants to communicate with. Then comes the a neighbor advertisement message. It's the response sent by a node to the neighbor solicitation message. And neighbor advertisement message is sent because a node wants the other to know that its link address has changed. But if you think that the same holds true for 6LoWPAN devices, it's not so. Here we have a different concept. As I said, each device is not on every time. There is this registration part. RS, router solicitation, or router advertisement, RA, they are the same, but there are two new messages which is called as node registration and node confirmation. So what do you mean by node registration and node confirmation? Node registration and node confirmation, as explained by the IETF website itself, is node registration is a message sent by a node to a router to register a binding. Similarly, node confirmation is the response sent by a router back to the registering node. If you want to know more about it, you can refer to the IETF link that I will be displaying in the description below. The other feature of the 6LoWPAN is its mobility. There are some key processes like roaming. Roaming, it's the movement of a node from one network to another. It will be explained shortly when we will discuss about the node mobility. Then there is this handover part. Handover is the point of attachment, where the point of attachment changes, and it will be discussed in what you call as network mobility. So if you categorize these mobilities, there are two categories. One is the node mobility, and in the node mobility there falls these two categories, that is micro mobility and macro mobility. Micro mobility is when a node moves within a 6LoWPAN domain. That is, here this node has dislocated from its original position. So what happens is that the prefix that stays the same, the IPv6 prefix that stays the same, but rest of the IP address might change, rest of the part might change. Then comes the macro mobility, when a node tries to move from one 6LoWPAN domain to another 6LoWPAN domain. Here the IP address changes. It means the prefix also changes, the whole IP address changes here. Then comes the another category, which is the network mobility. Here the entire network moves. So this is where the handover part involves. The complete point of attachment changes. It was initially here, now it has changed to a different. So You can think of it as a truck that contains hundreds and thousands of sensors, and as the truck moves from one place to another, its point of attachment changes, and the link can be anything. The link can be a wireless or a satellite or anything that will allow it to happen. Now, if we want to do some simulations in Cooja, Cooja is a simulator. It makes your computer or laptop behave like these IoT modes, and it comes as a tool in Contiki. So we will do some simulations. We will try to find out whether a given set of modes they allow the 6LoWPAN, they support the 6LoWPAN protocol in their network layer. So for this you need to have the Contiki operating system, and that Contiki operating system is available on the website. You also need to have this VMware so that you can mount your Contiki operating system on that. So user is the password for this. User is the default password for this Contiki operating system. You can go there, then you need to open the terminal, wait for it for some time. So here is our terminal. So once we are in this, we log on to this operating system, we have to press terminal, and after the window appears, terminal window appears, we have to type these commands, which is cd contiki tools Cooja. Now you have to press another command, which is and run. If it runs successfully, a Cooja window will appear. Then we will start our simulation, and these simulations will be related to the test. We will try to find out whether a given mode supports the 6LoWPAN in its network layer. We will start with MicaZ mode, then we will try with ESB mode, and finally we will try with Sky mode. So the window has appeared. We'll give a name to this simulation. Let's click new simulation, keep the same name, and press create. So all these windows will appear. Now we will select a mode, add mode, create new mode type, and let's start with MicaZ mode. Now once this window appears, we have to click on the browse. We have to look for IPv6 application, and in IPv6 application we look into RPL UDP, and in RPL UDP we look into UDP client.c. Now we open it, we try to compile it. If it gets compiled successfully, only then we can create. But here we can see that an error has occurred. which means that we cannot compile it. When we cannot compile it, we cannot create it. So this clearly means that Mica Z mode does not support 6LoWPAN in its network layer. So let's close it. Now again we will try to test for another mode, which is ESB mode. ESB mode will go to the same folder, which is IPv6, RPL UDP, and UDP client.c. Open. We try to compile it. Again, it has shown an error. We cannot create it. Therefore, it again means it does not support 6LoWPAN in its network layer. Now let's try with another mode, which is Sky mode. If you want to know more about Sky mode, I have given a blog. I have written an article about it, what Sky mode means. These actually are the T mode Sky. These are also IoT devices, and I have given a description about it in my blog. You can refer it. Now we have to press browse. We'll try with UDP client again. First we need to go to IPv6 and RPL UDP, then UDP client. Open. We compile it. So something is happening. Seems it will get compiled successfully. Now it has compiled. We can create it. So we can create as many modes as we want. Let's set the number to 3 or 4 or 5, whatever you want. Let me choose 5. Add modes. So there are these 4 modes. We want to make it much more lucid. Let me press on this mode IT. It will show the IDs, then address. If it has IPv6 address, then radio traffic. It will show how the packets flow. Then the grid, then also mode type. It will help us to distinguish between clients and servers. Now let's again choose. So far we have put these clients, 5 clients, into our network window. Now let us try to make servers. Create mode. Again we will go to Sky mode. Similarly we will press the browse. We'll go into IPv6 folder. Here we will look for the RPL UDP. RPL, it was UDP client. Now we will get to UDP server. Press open, compile it. It got compiled successfully. Now we have to press create. Let's keep 2 servers. Add modes. So there are 2 servers. So if you press on any of these modes and you want to find their radio range, you can go to radio environment. Now if you press into any, it will show its radio range. Similarly, if you press on 7, it will show its radio range. If you press on 1, it will show its radio range. Now we want to find out whether they support this 6LoWPAN in its network layer. For that we will press on tools, and this tools, there is a radio message. A new window will appear and we need to analyze the packets. So when we need to analyze the packets, we have to analyze the 6LoWPAN analyzer with PCAP. Now if you press the start button, you will see how the traffic flows in this network. You can see all these IPv6 addresses here, and at the same time you can see this radio message, the 6LoWPAN packet analyzer. So we have done it successfully, and Sky modes, they support 6LoWPAN in their network layer. So that was all. Thanks for watching. uh, Goodbye.